Jai Hind everyone. Today we'll complete the last topic of chapter 4 of class 11th physical geography, that is movement of the Indian plate. So in this we'll in detail learn the formation of Himalayas. Uh, let's see the topic. The Indian plate includes peninsular India and the Australian continental portions. Let's see the Indian plate once. Here, if we see, this is the Indo-Australian plate. So this is what it is saying, that the Indian plate includes peninsular India and the Australian continental portions. The subduction zone along the Himalayas forms the northern plate boundary in the form of continent-continent convergence. So here, if you see, the Eurasian plate is a continental plate, and also the Indo-Australian plate is also continental plate. In convergence boundaries, we have learned three types. That is continent-continent convergence, continent-oceanic convergence, and oceanic-oceanic convergence. So here it is the continent-continent convergence that makes the northern boundary of the Indian plate. So what happens in continent and continent convergence? One of the continental plates, which is heavier and has high velocity, will settle below the other continental plate and it uplifts it. But plate will not melt. So this is what happens under continent and continent convergence. In the east, it extends through Rakhine Mountains of Myanmar towards the island arc along the Java Trench. So if you see here, it has been extended from here. This is the Myanmar, if you see. So these are the Arkanyoma Mountains of Myanmar. If we come along here, we have Java Trench in the Indian Ocean. It extends along the island arc, which is Indonesia and all, Java Trench. This is in the east. And the eastern margin is a spreading site lying to the east of Australia in the form of an oceanic ridge in southwest Pacific. The western margin follows Kirtar mountain of Pakistan. It further extends along the Makrana coast and joins the spreading site from the Red Sea Rift southeastward along the Chagos archipelago. Here, if we have Pakistan here, Kirtan Mountains along here, and the Red Sea here. Here we have Chagos. So this is the western margin. The boundary between India and Antarctic plate is also marked by an oceanic ridge, that is divergent boundary. So what is the boundary between India and Antarctic plate? That is divergent, running in roughly west-east direction and merging into the spreading site a little south of New Zealand. India was a large island situated off the Australian coast in a vast ocean. So what was the earlier position of India? That is to the that is situated off the Australian coast, which is in a vast ocean. The Tethys Sea separated it from the Asian continent till 225 million years ago. So, if you think this India is situated off the coast of Australia, the middle part between Eurasian plate and India was Tethys Sea, which was separating the both about till about 225 million years ago. India is supposed to have started her northward journey about 200 million years ago at the time when Pangea broke. So in continental drift theory, we have learned that around 200 million years ago, Pangea started to split into Laurasia and Gondwana land. So that is the same time when India started her northward journey. India collided with Asia around 40 to 50 million years ago, causing rapid upliftment of the Himalayas. So, about 225 million years ago, Tethys separated the both, and 200 million years ago, India started her northward journey. But around 40 to 50 million years ago, India collided with Asia and caused rapid upliftment of Himalayas. The position of India since about 71 million years till the present are shown in figure 4.6. So if you see here, this is around 71 million years ago, where India is still under southwards of the equator. Around 51 million years ago, near to the equator. Uh, by 38 million years ago, it has almost crossed the equator. And by 10 million years ago, it has been collided with the Eurasian plate. It also shows the position of Indian subcontinent and the Eurasian plate. About 140 million years before the present, the subcontinent was located as south as 50 degrees latitude. So if this is the equator, and if we assume that this is the 50-degree latitude, this is the distance between the equator and India around 140 million years ago. The major two plates were separated by Tethys Sea, and the Tibetan block was closer to the Asiatic landmass. During the movement of the Indian plate towards the Eurasian plate, a major event that occurred was the outpouring of lava and the formation of Deccan traps. So, as it is a conversion, the destruction of the crust takes place, and due to the magma from the mantle wedges into the crust as lava. This started somewhere around 60 million years ago. So, when did the formation of Deccan traps happen? Happened around 60 million years ago and continued for a long period of time. Note that the subcontinent was still close to the equator. From 40 million years ago and thereafter, the event of formation of Himalayas took place. Actually, there are 5 stages we need to read to understand the formation of Himalayas. I will show once. So in this PDF, I've written the details regarding the 5 stages of formation of Himalayas. I will be attaching the Telegram channel where I've uploaded the PDF. If anybody wants, they can download it from there. Next, scientists believe that the process is still continuing and the height of the Himalayas is rising even to this state. So that is why the Himalayas are called Fold Mountains, because the height they are still the height of the Himalayan region is still growing because of this continent to continent conversion between Eurasian plate and Indian plate. So this is all about chapter 4 of class 11 physical geography. Let's have a quick glance at the chapter and the topics we discussed. So starting, we have learned the continental drift theory, which was given by Alfred Wegener in 1912. It says that around 200 million years ago, there was a single continental mass called Pangaea, and it was surrounded by a large ocean called Panthalassa. But around 200 million years ago, the Pangaea began to split into two large continental masses called Laurasia and Gondwana land. And we have learned certain evidences that support continental drift theory, like matching of continents, rocks of same age across the oceans, tillite, placer deposits, distribution of fossils. And then we learned what are the forces that are driving the drift in continents. And we have learned briefly about convectional current theory and the mapping of ocean floor configuration and how it helped to understand the movement of continents. And we also learned the major divisions of the ocean floor, that is continental margins, deep sea basins or abyssal plains, and mid-oceanic ridges. And we have learned distribution of earthquakes and volcanoes. Here, this is the Pacific Ring of Fire, or also called Pacific Rim. And then we learned seafloor spreading, which was given by Hess in 1961, based on the magnetic properties of rocks on either side of mid-oceanic ridges. And then we learned plate tectonics, which was given by Mackenzie, Parker, and Morgan in 1961. In this, we learned the major tectonic plates and the minor tectonic plates, types of boundaries like constructive, destructive, and transform boundaries, the different speeds of different plates, which is the fastest, that is East Pacific rise near Easter Island, and which is the slowest, that is the Arctic ridge. And force for the plate movement, this is where we have learned about convection cell or the convective flow. And then in the last, we have completed the chapter with movement of the Indian plate. So this is all for chapter 4. Let's see with the next chapter. Thank you.